how to write a. So this is one example for AND gate test bench. Okay. So first we need to write normal module for the AND gate. Okay. So after writing the code, we have to have that code in the current folder. So we are including that AND gate code. That is include and the name of your file .verilog. Okay, this you need to include into your whichever workspace is there. Okay, for this verilog we are writing the test bench. So first, as usual, in the verilog to create a module and the name of the test bench file. So same name you have to give. Okay, so whatever is the name of your file underscore dot underscore tb semicolon. When you do in the stimulation, automatically this will come. Okay, so how to know means it will be written as underscore tb. This is the test bench for this gate. Okay, so this is the first line. After that, so we know that AND gate has two inputs and one outputs. Okay, so all inputs set as reg in a, let it be any combination logic circuit, all the inputs should be declared as reg. So since it has two inputs AB, then similarly all outputs are declared as y. So we have one output, so y as n. And this is the module, the same module which we have come, we are taking the instance of this test bench. So and underscore to behavior instance name, that is ind csdo bracket output and inputs. Okay, instantiation of this test bench module. Okay, afterwards now we have to give the values to a and b. How to give, you see. So this is your initial begin. So this is the loop, initial begin end. Okay, this will work. Similarly, one more initial begin end. We are doing this. So in initial begin end, first we are making a b, because a will take the values either 0 or 1. So since it is binary, so a is equals to 0, b. So starting after 1 nanoseconds, okay, this hash 1, after some you can give delays. If you want more delay, you can write 10 nanoseconds, 20 nanoseconds, whatever you want here. Then you're making a0 b1. This is one more combination. After some more time, say 1 nanoseconds, a is equals to 1, b is equals to 0, and a is equals to 1 and b is equals. So all combinations we are writing. You can change the timing if you want to change. Okay, so this is the how to write the inputs combinations to this circuit. Okay, we are closing this. After this one, you have to monitor the outputs. So monitoring the outputs we have written in this initial begin end. Okay, initial begin this file. So dollar monitor, okay, percentage d hash a type. So a we want to monitor, so percentage. Similarly b we want to monitor, b is equal percentage d and y percentage comma dollar symbol time, and that means you want to display the time this, then you want to see a b and y. So a b and y, so time a b y all will be displayed in this. Okay, test bench. Same that you want to dump into your file or the waveforms, you can write like this. Okay, this is optional. End module and end, this is the initial begin and end module. Okay, so this is how. So this you can write even for a OR gate. Same test bench you can use for OR gate. To input any gate you can use this. The variables are a b and output is 1. For AND gate or like AND gate, OR gate, NAND gate, which are two inputs, you can use this test bench. Only this single test bench can be used for all the logic gates. Okay.